Hi, I'm Mary Ann Schilling, UW Extension Family Living Educator in Waushara County.
And I'm Cody Frederick, a community health educator with UW Carbone Cancer Center.
We're going to demonstrate the abnormal cell growth activity.
So helpful materials for this activity include a large paper cutout of a lung and liver with these yellow dashed lines to represent road lines, 2 packets of solo cups in 2 different colors. A few of these solo cups of both colors should be marked with a red X.
This activity can also be done at an individual level with the smaller lung and liver cutouts and paper ketchup cups.
So have participants sit in a circle surrounding the 2 organs, lungs and liver. If there are more than 10 participants, separate them into groups. Give each group or 2 different participants a different color of solo cups.
At this point you can say, the solo cups represent the cells of our organs. Our cells are arranged in an orderly fashion, much like our highway systems. Have the participants put the cells in small stacks on the highway in an orderly fashion.
At this point say, cells are constantly copying themselves to replace old, damaged cells. Normally, cells grow, copy, and die in an orderly fashion, much like cruise control. Each stack of cups represents the infinite number of times that a cell can copy. Have participants take a cell off the top of the stack to demonstrate that cells usually copy in an orderly fashion.
At this point you can say, sometimes the cell's copying instructions, known as DNA, can be damaged by a hit. This can result in a mutation or a change in the cell structure. A hit can come from what we are exposed to, such as environmental factors, viruses, etc., or how we live, such as the diet that we eat, if we use tobacco, and if we misuse alcohol, etc. Then you can have participants simulate a hit, like smoking, to one cell by crushing the cup.
Say, generally, our body responds by either the cell self-destructing or the immune system destroying the mutated cell. In some cases, the mutated cell doesn't die, but begins to reproduce or copy at a faster rate. The mutated cell produces more mutated copies of itself. Think of it like a Xerox machine. If you make one copy with a smudge on it, all future copies will have that same smudge. Have participants simulate mutated, crushed cups copying at a fast, uncontrolled rate. Then say, the risk of those mutated cells developing into cancer depends on the number of hits, their frequency, and their intensity. So if you smoke a lot and do it often, your risk of a cancer cell mutation may be higher. The facilitator can add cups with a red X to denote a cancerous mutation to one of the cell masses.
At this point you can say, uncontrolled cell growth is like an accelerating car. The gas pedal is stuck in an acceleration mode. Cells are reproducing at a faster rate than needed. If there are too many cells on the road, a pileup happens. This pileup is called a tumor. Tumors can be benign or malignant, which means non-cancerous or cancerous. As you can see here, one of the pileups has cancer cells and the other does not. The one that doesn't is benign, and the one that does is malignant. Have each group or each participant deconstruct the abnormal cell growth demonstration and reteach it back to others. Thank you.